Hello, today we have a presentation for Neurobiology 4500, created by Izzy Richardson and Christiana Warner. Today we're going to provide a little scientific insight to a common phenomenon in humans, sneezing. Now, I know what you're going to ask me. What does sneezing have to do with neuroscience? Well, I would answer your question with another. What do you think of when you think of neuroscience? Most people would probably think, well, neuro means brain science. And yes, you would be correct. While the brain, being part of the central nervous system, is a large part of neuroscience, most people forget about the peripheral nervous system. This consists of nerves spanning throughout your entire body. So really, there's much more to neuroscience than one might think. And yes, it even has a factor in sneezing. First, we're going to start with the basics. What is a sneeze? A sneeze is a protective mechanism that your body uses to clear its nose. First, an irritant will enter through the nose. This could be things like dirt, pollen, smoke, or dust. Once entered, the membranes inside the nose become irritated, causing a sneeze. But what's the science behind this? To understand the science behind a sneeze, we must first have an understanding of the cellular anatomy of the nose. Outlined in black, you'll see large pink cells with a darker nucleus inside. These are going to be your epithelial cells. Epithelial cells serve a variety of functions, like creating a physical barrier, aiding an immune system function, and playing a role in the body's inflammation response. The goblet cells are going to be integrated in with the epithelial cells, as you can see with the shaded region. These cells are going to be responsible for mucus secretion. If you look closely on top of the epithelial cells, you'll see small, hair-like structures called cilia. These cellular structures transport mucus in a process called mucociliary clearance. This process is essential in keeping foreign matter out of the body. Lastly, and what makes sneezing a part of neuroscience, is the trigeminal nerve. Many distal branches of the trigeminal nerve terminate in the facial skin, transmitting tactile, pain, and temperature sensations, while some branches distribute into the nasal mucosal epithelium, which is what we see here. Now we are going to start identifying all the different nerves that you have in your face. Afferent neural stimuli are transmitted to the trigeminal ganglion via these four parts of the trigeminal nerve: the anterior ethmoidal branch, the posterior nasal branches, the infraorbital branches, and the ophthalmic branches. The trigeminal nerve divides into three nerves distal to the trigeminal ganglion. The ophthalmic nerve passes forward in the lateral wall to the cavernous sinus. It then enters orbital via the superior orbital fissure. Maxillary nerve leaves the skull base through the foramen rotundum ossis spinalis, infralateral to the cavernous sinus. It then enters the pterygopalatine fossa, giving off several branches. The main trunk then continues anteriorly into the orbital floor and emerges onto the face of the infraorbital nerve. The mandibular nerve runs laterally along the skull base and then exits the cranium by descending through the foramen ova into the masticator space. The motor root of the trigeminal nerve bypasses the trigeminal ganglion and reunites with the mandibular nerve in the foramen oval basis cranii. Hence, this is the only branch which contains both sensory and motor components. The ophthalmic and maxillary nerves contain only sensory fibers. The phrenic nerve provides complete motor innervation to the diaphragm and sensation to the central tendon aspect of the diaphragm. It is what tells the diaphragm to contract and vigorously expel air. So here we see the anatomy of the trigeminal nerve terminations. So up top we have the receptor endings, then it has the myelinated fibers, which leads down to the trigeminal ganglion. There are three sensory nuclei that feed into the trigeminal nerve. The first is the mesencephalic nucleus, the second is the main sensory nucleus, and the third is the spinal nucleus. There also is the motor nucleus of the trigeminal nerve and the motor root as well. Now that we've gone over all of the nerves involved when you sneeze, let's start to look at how it all comes together. There are two stages of sneezing. Stage 1 is the nasal or sensitive phase that begins with the stimulation of nasal mucosa by something irritating it. That eventually leads to the sneezing center of the brain. Stage 2 in sneezing is the respiratory response in which you physically close your eyes, take a deep breath, and sneeze. Here we are seeing the irritants being inhaled. They travel up through the nasal pathway. We see them stimulate the receptor endings. Once the receptor endings are stimulated, it then travels down the myelinated fibers to the trigeminal ganglion. We see that here. Then to the 3 different sensory nuclei. This then triggers the 2 different pathways, the parasympathetic nuclei, which leads to increased nasal secretions and tear production, and the motor nuclei, which triggers the pharyngeal, laryngeal, and respiratory muscles. This diagram shows the nerves coming from the medulla to the diaphragm, triggering it to contract and expel air, thus leading to a sneeze. Thank you for watching, and I hope you learned some about sneezing and neuroscience.